It's pretty good, and it does what we want. But tomorrow I get 10 new files to analyze, and I want to analyze them. What do I have to do? Sorry, what?
You have to analyze all of the new files.
Yeah, so I have to rewrite this loop, and then the day after, if I get some new ones, I have to rewrite the loop again. And at some point, I might just forget what the loop was. It would be nice to put the loop in a text file and just copy it over, right, every time. And that's exactly what we're going to do. We're going to make a text file which will have our loop in it. And it turns out that that text file doubles up as a reference, as well as some kind of program that we can execute. Let's see how that works. Go ahead and create a file called analyze. .sh. The sh stands for the shell or bash. We use these terms interchangeably, and the shell is just what you're using right now. And within an sh file, you can have, or within this file, you can have some Unix commands that you want to run, and we'll just put our loop here. So for file in any star.txt to bash stats file echo Remember, this is just our loop, and it's in a file. And the neat thing is that this file is now what we call a shell script, which means we can execute it in some sense. We can execute it using the bash command. So if you type in bash analyze.sh, it will just run all the commands that live inside analyze.sh. And so that's just one more way of being lazy, is where you type in the commands only once, put them in a script, and every time you want to run them again, you just run the script. And if you've worked with any programming language before, MATLAB, for example, this is something like an M file. It's just a script that has commands that you want to run. And the program that you're using to run it is bash. If you try and run it with some other program like Python, for example, that doesn't make any sense because Python doesn't understand this syntax. The only program that understands the syntax or the words inside analyze.sh is the Unix shell bash. And so you have to run it with bash. Okay. We're just going to look at a few miscellaneous commands now to do some very useful things. Let's say I want to remove all my output files. How do you think I can do this? I want to remove all the files that begin with output. Output star.txt. Excellent. And I'll do the same here with result. Of course. You have to be very careful when using RM, and that's because there is no recycle bin in Unix land. If you've RM'd a file, it's going to be pretty much impossible for you to recover it. So be careful when you RM things. So anyway, I've removed all these guys. And let's have a look at one of our files again, NENE 0204a.txt. Here's how it looks. Remember, the first column is the protein number, and the second column is how much of that protein is there. In a single line, here's what I want to do. I want to get the amount of protein number 178. How would you do this? If I asked you to do it with the knowledge you currently have. Look at this file, NENE0204a.txt. and give me the amount of protein number 178. How would you do it on a Windows machine or on your Mac machine?
First find that protein and then see how much it has.
Yeah, so step 1, open the file. Step 2, keep in mind the protein number, scroll down the file, and then look at how much it has. Okay, that's one way and it works. It works every time. But of course, this is a bad approach, right? We're learning that. Okay, any more ideas?
Search control F.
You can use Control F, and that is a very powerful tool. Unfortunately, if you want to do the same thing on all your files, it's not going to be very easy. You have to hit Control F at least 1,000 times if you had 1,000 files. Any other ideas? Yes?
Write a bash script to find the protein.
Write a bash script to find the protein. Okay, what would you put in that bash script?
Well, I mean, can you put conditionals in?
Ooh, wow, okay. Yeah, you could do that. But there is a very nice command, unfortunately called grep. And grep expects a pattern that you want to match. And in this case, we'll just grep for protein 178, or the number 178. And then the file that you want to locate this pattern in. Let's see, 17298. And that will print every line that contains this pattern 178. Grep stands for, I've got no idea, something to do with regular expressions. Sorry, what?
Global regular expression pattern.
Global regular expression pattern. Okay, but in general, you can think of grep as some kind of finding tool. If you want to look for something in a file, you want to grep for it. In the days before Google, when people talked about searching for things, the same way we say Google it, Unix users say grep for it. And so here we're grepping for 178 in our file any017298.txt, and that will return all the lines that have this pattern 178. You see it, 178 here, 178 here, 178 here, and here. But is this what we want? It's not. It's almost what we want. It's much better than what we had, but it's not what we want. Fortunately, grep understands patterns like star, for example. You can say grep star 1 star 8, and grep will match every line that has this pattern that begins with 1 and ends with 8. So here we have 1 and 8. Let's see. That didn't really work, did it? Huh. Well, you know what? I don't want to make a fool of myself. One of the patterns that you can use in Unix is hat, which I think refers to the beginning of a line. And so whenever you use the hat character, that matches the beginning of a line, which means that this pattern looks for the number 178 at the beginning of a line. Similarly, you can use the $sign to match the end of a line. So for example, if I said $4, that would match all the lines that end with the character 4. And so if I grepped for $14 in any 017298.txt, you get all the lines that end with 14. And I can't resist myself, but I have to do 350. All right. Okay. All right. So there we are. Grep is useful for matching patterns in files. So whenever you want to look for things in files, you can use grep. There are other commands that you can use to search for things. For example, from within the data HPC directory, or let's go into let's say that from within this directory, you wanted to locate all the files that end with .txt. And when I say all the files that end with .txt, I don't mean in this file, but in all the direct, not just in this directory, but in all the directories under it. So when you're looking for lines in a file, you can use grep. When you're looking for files in the file system, you can use find. And find works in much the same way. It expects where you want to start looking from, and then it expects a pattern. And the pattern needs to be provided as the name switch. So here I'm looking for all the files starting from my current directory dot, which have the name star.txt. And you see that returns for you a list of files that all match this pattern star.txt. And it tells you where each one of those files are. You see that we created these files, sorted.txt and that's.txt, they're inside molecules. We have all our input files here. And we have some other text files that we haven't seen before. But the idea is you don't have to really know how or what the syntax for using find and grep are. You can always Google that. But all you need to know is that if you're looking within a file for a word or a pattern, you can use grep. And if you're looking in the file system for a file or a folder, you can use find. This works a lot like Control F, and this works like some kind of search in my computer. Does this make sense? All right. I guess you know what? I'll stop and not really fill your minds with too much more. So there it is. We learned a lot of things today. We learned how to log into the cluster, which is important. We learned how to navigate the file system. We learned how to create pipelines. We learned some useful commands like word count, find, and grep. We learned how to write loops. And then we learned that we could put Unix commands inside scripts. And then we could execute those scripts, and that would just run all the Unix commands inside them. And again, that's a lot of Unix knowledge. So if you're familiar with these concepts, that forms a very strong starting point for you to start using Unix effectively.